Welcome. Hi. How you doing? Good to see you. Welcome back to another video. We're talking about trig, but before we do, let's go. Why did the computer go to the optometrist? Because he had a poor website. Eyesight. Okay. Non-right angle trig. Okay. One of my teachers always used to say in advanced mathematics, there's only ever two types of triangles. There's either right angled or non-right angled. We've done Pythag, we've done SOHCAHTOA. That's all right angled. Now we're going to venture into this world of non-right angled. So you'll see things like sine rule, cosine rule, and another area for a triangle formula. We're going to see those today. Now the basis of all of this non-right angled trig is you've got to know how to label a triangle. Okay, now we label it in a very specific way, and it's going to go like this. So first things first, your capitals become your vertices or your angles or your corners. So in other words, that's angle A, that's angle B, C. And then your lowercase is your sides. Now, the way that it works is your sides have to correspond to the opposite angle. Okay, so that means if that's A, the opposite of that side must be lowercase a. So if that's giant B, that's the angle B, the opposite side will be side B, and same thing for side C. Hopefully that makes sense. Let's apply it. So now what we've got here is we're going to find the sides and angles of non-right angle triangles using this thing called the sine rule. It's the sine rule because it uses sine. Okay, and it's given by A on sine A equals B on sine B equals C on sine C. The inverse is also, not the inverse, sorry, the reciprocal is also valid. I could write sine A over A equals to sine B over B equals to sine C over C. Now, if you take a look, what it's saying here is that it shows that an angle kind of affects the length of the opposite side. So in other words, if I had a large angle here, I would have a fairly large side there. Or if I had maybe a smaller angle here, my side on this side is going to be slightly smaller because it relates to the opposite side. And so essentially what you're looking for is you're looking for some sort of crisscross. That's the hint that I'm probably going to use the sine rule in this case. Okay, let's take a look at an example. Let's find a side and let's use the formula to do that. So first things first, can you kind of see that we have this, there's a side and an angle, there's a side and an angle. Okay, they're opposite. There's a bit of a crisscross. I'm going to say that that is going to be some sort of sine rule. I like to start with what I don't know, and that is x. Don't know it. I'm going to put it in my top left-hand corner. Long story short, it's going to make my working out slightly easier. But that there relates to sine 30. And then it equals to the other ratio, which is the side. In this case, it's 13. It's going to be over sine of the related angle or the corresponding angle, which was 50. Now we're almost done. We just need to solve for x. And as you can see, we just need to multiply both sides by the sine 30. And that leaves us with 13 on sine 50 times sine 30. And I'm pretty sure that gives us something like 8.49 centimeters. And that would be your answer. Okay, and it makes sense. The larger angle has the larger side, and the smaller angle should have something. The angle should be smaller than 13, which in this case it is. That's that. If we want to find an angle, same thing. I'm going to look at my triangle and see, do I have some sort of crisscross going on? I do. It's not going to be always in the same kind of position, but I do see an angle and the opposite side, and I do see an angle here and the opposite side. Okay, so we've got this kind of crisscross going on, and from here, I know that's my hint. I'm going to use the sine rule. Now, this time, I always like to start with my unknown first. And so sine theta is going to be my unknown. Unfortunately, I can't just have theta. It's the sine rule, so I need to use sine. The side that it relates with is the 14. And I'm going to equal it to what I also know. The other one will be sine 60. And then sine 60 relates to the side 17. Now, very similar. I will now start moving things over. I'll times 14 to both sides to solve for sine theta. And the last step here is I would actually solve for theta. So in other words, now I do a sine inverse, and that's going to give me sine inverse of this whole thing. And hopefully if I do this right, times 14, you should get something like 45 degrees, and I'm going to talk about 29 minutes, 44.39 seconds. And so to the nearest minute would be 45 degrees, and it would be 30 minutes to the nearest minute. Okay. That's just extra. Okay, now there's one other little trick that they'll kind of put out there, and it's finding what we call an obtuse angle. So let me show you what happens when it comes here. Now, it kind of looks like theta is going to be an obtuse angle. Let's keep that in mind as we're doing this. Now I can see that that angle is going to relate to that side. And I can see here that this angle is going to relate to that side. So we've got this crisscross going on. It is the sine rule. Very similarly, I'm going to go sine theta over 22 equals to sine 13 over 12. I'm going to times both sides by the 22. Sine 13 on 12 times 22. And then I'm going to go theta equals and do the sine inverse of whatever that is. So theta is going to equal to sine inverse of sine 13 over 12 times 22. And if I close all my brackets, you should get an answer. I'll get something like 24 degrees, 21 minutes. Okay. Now that there is 24 degrees is not an obtuse angle, but this is the thing about sine. What do we know about sine in the second quadrant? Because obtuse angles mean they're in between 90 and 180. We know that sine is also positive. So in other words, I can do 180 minus theta, or in this case, it'll be 180 minus 24 degrees, 21 minutes. And that's going to be 155 degrees and 39 minutes to the nearest minute. Okay, hope that makes sense. Area of a triangle. Okay, now there's another formula that we use. I'm bunching it together. Hopefully you guys are okay. When you know the perpendicular height, please don't forget area of a triangle is just going to be half times space times height. Okay, half base height is nicer. I don't know why I did the times base times height. But here's the other one. When you don't know the perpendicular height, it's actually given by this formula. It'll be half AB sine C. Similar, but not quite. Now, the way that it works is, I probably should have written this as AB, and this would be sine C, because that one would be capital A, that one would be capital B. And you can kind of see here that with the formula, I've got A, B, and I've got sine of C. So it's kind of this little arrow thing. So the cosine rule was, the sine rule was kind of like a crisscross. This one just kind of looks like a TP, a little hut. That's my little hint that I've got the sine, the area of a triangle. Sorry, I'm rambling. Hope this makes sense. So I've got an example here. Find the area of. Now here I'm looking, and I've got a side, and I've got my included angle. So that's kind of my hint that, okay, I'm probably using area equals to half AB sine C. And so my A is, I can make it 14 and 16. The A and B doesn't matter too much. The most important is that it's sine of my angle on the inside. And that should give me my answer. Let's see if I've got something nice. 0.5 times 14 times 16 times sine 120. I don't think it'll be nice, but in this case, it'll be If this was centimeters, this would be 96.99 centimeters squared because it's area. And that's how you would apply these formulas. Hope that makes sense, and I'll catch you in the next video. Good luck and bye-bye.